Back. In this video, I'm going to show you how to solve an exponential equation numerically. So numerically means we're not going to use the graphing part of our graphing calculator. Instead, we're going to use the table feature. So like in the last video, we know that, well, we actually know what the solution to this equation is, so that's unlike the last video. But we know we're looking for a number that's in between 2 to the first is equal to 2, and 2 squared is equal to 4. So we're looking for a number between 1 and 2. That's going to be x. So we break out our graphing calculator, and we're going to use the table feature, so quit. So my y rule here is 2 to the x, y1 is 2 to the x, and y2 is 3. Now I'm going to go to table set. I'm going to set up my table. So I do second window to get to table set. And my start, it's starting at 0 right now. I want to start at 1 because I know that x is going to be between 1 and 2. So I'm going to start at 1, and the delta table, actually let's just see what it looks like right now. Enter. So now I'm going to hit second graph to get to table. And you can see the x values are going up by 1. And then here are my output values. So 2 to the first is 2, 2 squared is 4, 2 cubed is 8, 2 to the fourth is 16, and so on. But I'm looking for where y1 is equal to 3. And so it looks like it's going to be like in between 1 and 2. So what I do numerically now is I go back to my table set menu, and I'm going to go up, instead of going up in increments of 1, I'm going to go up in increments of 0.1. And so now I go back to my table, and now you can see I'm going up 1, 1.1, blah, 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 blah. So now I go down this column, and I'm looking for where the values go from below 3 to above 3, and that's between 1.5 and 1.6. This 1.5 is going to be my new table starting value. So second table set, table start, I'm going to start at 1.5. And instead of going up in increments of 0.1, I'm going to go up in increments of 0.01. And now I go back to table. And I can see 1.5, 1.51, blah, blah, blah. So I'm looking for where these y1 values cross from being less than 3 to just above 3, and see that happens between 1.58 and 1.59. So my new starting value is 1.58. So I go back to table set, and table start is going to be 1.58. And now I'm going to go up in even smaller increments. Instead of going up every hundredth, or 0.01, I'm going to go up every thousandth, or 0.001. And now I go back to table. And now I can see, okay, where do I go from below 3 to above 3? And that's between 1.584 and 1.585. So my new starting value can be 1.584. This is what we call an iterative process in math. It's kind of boring, but it gets us there. 1.584, 1.584. And I'm going to try going up instead of every thousandth. I'm going to try going up every 10,000th, 1.01, or 0.0001 graph. And here you can see 1.5849. I go from 2.9999 all the way over to 3.01. So numerically, I'm getting in the ballpark. So I'll take a picture of this and copy it, and then paste it here. And that's how I can use my graphing calculator to solve numerically. I just keep drilling down, drilling in, zooming in, getting a new starting point. I'm looking for where my output values cross from being less than 3 to just above 3. Y2, we didn't talk about that. Y2, remember when we have that in the graphing calculator, it is just that flat line, y2 is equal to 3. So I'm looking for where y1 is equal to y2, and that's going to be somewhere in between there. So I could keep drilling down and get to this number that I got when I solved it graphically, 1.5849625. So here, the solution, I stopped after I got to like 4 decimal places. Here, the solution is going to be somewhere between 1.5849 and 1.585. So if I were to write the solution here after solving it numerically, I would say x is approximately equal to 1.5849 dot dot dot. And that's how I could solve numerically. We're forced to solve numerically or graphically when for some exponential equations. They're going to be our messy exponential equations. They're ones where the value we're looking for, we can't represent it as an integer power, or not an integer or rational power of the base that's on the left-hand side. So we are forced to solve it graphically or numerically at this point in time because we don't have another analytical tool. We need another tool to solve. So if you're confronted with an exponential equation and you can't get the bases to be the same, solve it graphically, solve it numerically. I'd solve it graphically. And it's a lot easier to solve it graphically on Desmos than it is on using these TI graphing calculators, but you can use the TI graphing calculators on tests and standardized tests. So it's good to get your calculator skills sharp. What we're working towards in the next video is, instead of solving graphically or numerically, there's some exponential equations that we can solve directly algebraically, and that's where we're headed next.